In this exercise, we're going to use k-mean clustering to understand the structure of this data coming from the FT Global dataset. This is basically a ranking of companies based on variables such as value, turnover, income, assets, price to earning ratio, and yield. We would like to group this data using clustering, and we want to calculate the mean of the clusters based on each one of the features. Second, we want to get to understand what these clusters mean. Because we don't know how many clusters exist in the data, we probably want to try a couple of values, including a range of number of clusters from 2 to 4. And then we want to examine our interpretation of the data again. So first, let's import the data. And second, let's plot the data. What I'm going to do here, I'm just going to create a scatter plot just relating the market value in million of dollars to the price to earning ratio. Let's import the package Altair. As well as other needed packages for this exercise. So if you take a look at this data, this plot shows that for companies that have a low market value, there is a high variance in terms of the price to earning ratio, the stock price to earning ratio. Once the market value increases beyond a certain point, we can see that this variance decreases substantially. Next, I'm going to create a k-means clustering model. Once again, we need to specify the number of clusters as one of the hyperparameters. Let's do 2 clusters here. Second, we want to extract the feature matrix here. In this example, we're just starting. I'm just going to focus on 2 features, the market value in million of dollars and the price to earning ratio. So I'm going to do 2 things. First, I'm going to drop the null values from my data. Once again, all of those machine learning models do not know how to handle null values. So we either have to drop the null values or we have to fill them or impute them somehow before applying the model itself. Next, I'm going to get my X to be data 2, market value in million of dollars, and also the price to earning ratio. That's my X. Next, I'm going to fit the k-means model to this data. And I'm going to predict the clusters that each point belongs to. So I'm going to k-means predict the X of each one of them. I'm going to add this data to my data frame now. So I'm going to add this as a column to data 2, call cluster to be Y of k-means. So now if you look at data 2, you can see that for each one of these observations we have a cluster. Now what do these clusters mean? One way we can do a group by clusters, and then we can take a look at these features, market value and price to earning ratio, and then we can either take the average or we can describe it. And if you take a look at these 2 clusters, you can see that cluster 0 corresponds to companies which have somehow a lower market value and a price of earning ratio hovering on average of 20, versus the other one, cluster 1, is kind of picking up companies that have a large market value in million of dollars. Another way to know what these clusters mean is to visualize them. So we can use the same plot that we had here, and this time is going to use data 2, and I'm going to encode color to map to cluster here. Here you can see that the second cluster, cluster 1, is picking up companies that have a large market value, versus the second one, which is picking the companies that have a low market value. And again, here you can see that the clustering itself is picking on the first feature. The second feature doesn't seem to matter a lot. So that's important here and is interesting, because now the clustering kind of figured out the distribution of companies based on their market capitalization. Now we can repeat this exercise by adding more and more features, right? So we can add value, turnover, income, assets, and price to earning ratio, as well as yield. So there are many features here that we can add. The only thing we need to we will miss when we add all of these features to the feature matrix is that it will be more difficult to visualize. So we will resolve to interpreting clusters by looking at the averages of these values, but unfortunately it won't be as easy to create visualizations once we have more than two features that we want to visualize. So what I'm going to do now, I'm going to basically repeat the same process, but I'm going to collect much more features columns here, and I'm going to select the features that the question is asking me about, which are the value, turnover, let's take a look. So the value itself, which seems to be C value, market value, we already captured this, and then we have turnover in million of dollars, which is this one. Next we have assets, which is the total assets. Let's keep PE ratio, which is the total assets here in million of dollars. And then we have price of earning ratio, which you already got, and then the yield, which is the dividend yield percentage. So that's my new feature matrix. And the remaining steps are very similar. I need to create my k-means. And I want to do, well, I want to vary the number of clusters, but for now, let's do 2 clusters now. And then I'm going to fit the data itself. I'm going to fit my x and predict the y of the k-means. So I'm going to fit the new x. Some of those are not numerical variables, so we've got this issue here. Let's take a look at x and figure out which one is not numerical. It's this one, right? So turnover not reported, it means it's not a number. So that's a data quality problem. So what I'm going to do here in data 2, I'm going to do data 2 is, well, it's only an issue. Well, let's take a look at the D types here. It's only an issue with turnover. So what I'm going to do here, I'm going to convert data 2 turnover to a number using pd.toNumeric here. And of course, this is going to give me an error because it doesn't know what to do with NR. So I'm just going to do coerce to be true, or errors coerce the error to null values. That will give me nulls. So what I'm going to do here, I'm going to put that again into data 2 turnover. Once I'm done with this one, I want to drop the nulls again. So once I do this, I'm going to drop the null values again. Well, I got rid of that. This I don't need anymore. I'm going to extract my x's and fit my k-means clustering. Okay, now that I'm done, I can basically do the same process. I can look at what these clusters mean by just doing a group by operation. So I can do group by cluster, but instead of looking at 2 features, I can put all of them. So I can put all of my x features. I'm actually going to do x dot columns here. And that will give me how these clusters are different based on all these features. So you can see that the dividend yield is almost the same. Price to earning ratio is not a big difference. It seems that the 2 clusters are still picking on the size of the company as measured by the market value, turnover, total assets. But if we add more clusters, then we would expect the new clusters to pick up on some of these variables, such as the price to earning ratio and the dividend yield. For instance, if I do number of clusters to be 3 and do the clustering again, I need to put back cluster into the data frame again. So we forget to put clusters to be equals to k-means. So let's do it again with 2 variables. And that's probably because we dropped the data. So we need to do that once we fit the data itself. Okay, so what ky we need to predict. Y k-means is k-means dot predict the x, and then we want to put it back together. Okay, so now we do the clustering here. So let's look again. So it seems that with 2 clusters, it's still picking mostly on size. We don't see much difference in the price to earning ratio. There is some difference, but not a lot. If we make this 3 clusters, then I'm expecting to see some differences here. So you can see that cluster 0 is picking on small companies, cluster 1 is picking on medium-sized companies, and cluster 2 is picking on larger-sized companies. Once again, the price to earning ratio seems to be higher on cluster 0, but just having plotted that, we know that smaller companies have a more variance. So it seems that even with 3 clustering, the clusters themselves are still picking up on the size of the company. There are proxies of the size of the companies so far. But once again, we can vary this. We can make it 5, for instance. And now we have 5 clusters, and you can see that among these 5 clusters, many of the cluster, for instance, those are companies, cluster 1 and cluster 3, that have, relatively similar size in terms of market value and in terms of market value, not in terms of turnover and total assets, but they have still, I would say, kind of comparable dividend yield and price to earning ratio. So it's probably now discriminating based on the total number of assets. All right. So again, this is kind of an iterative process. It's trying to understand the structure of the data. And it seems to me, just going through this exercise, that the price to earning ratio and the dividend yield are not being, picked up by the clusters themselves. Probably at some number of clusters, we will see more substantial differences across these 2 variables.